Let's continue our discussion on interfaces with or at least what I consider to be a pretty cool example of how interfaces work. So let's consider the following problem. We want to be able to write an expression parser. Well, not a parser, an expression interpreter. Okay? So what do I mean by that? So let's consider the following things. What do these four things have in common? Well, they are all expressions. They are all mathematical expressions, okay? And our little expression interpreter, or evaluator, will consider four types of expressions. We have numbers, we have additions, we have subtractions, and we have multiplications, okay? So the question is, what is what is the commonality between all of these expressions? Or rather, what is the commonality between these four types of expressions? Well, the answer is that they can all be evaluated. Okay? So what do I mean by that? Well, it's pretty clear to see that the number 3 just evaluates to 3, or the expression 3 just evaluates to the number 3. Okay? The number 42, or the expression 42, resolves to the number 42. The expression 3 plus 4 is evaluated as follows. We have a plus of 3 and 4. The left operand is a 3, the right operand is a 4. So, to evaluate a plus, we have to evaluate its two operands. So, the expression 3 resolves to 3, the expression 4 resolves to 4, and then we just add the result of those two evaluated expressions. So 3 plus 4 gets us 7. Okay, and this one's a little more complicated, so let's break it up a little bit. So let's write a different expression. So we'll actually use a separate screen for this, but let's say we have 3 times 4 minus 16 plus 8 times 2. So, how do we evaluate this? Well, we first have to recognize that this is a subtraction, right? So we have a subtraction here whose left operand is this 3 times 4, right? So, it's a times of 3 and 4. The right operand is a plus, as we can see. So let's color code these. So this will be green, this will be red, and then this will be this blue color. Okay? So on the right side, we have a plus, right? Plus. And then its operands are the number, the expression 16, and the right is itself a multiplication of 8 and 2. The expression's 8 and 2. So, to evaluate this subtraction, we have to recursively evaluate the plus and the times, okay? Because we can't just do the expression that's a multiplication minus the expression that's an addition, because that doesn't make sense, right? But we know how to do the arithmetic if they are numbers. So let's go down the left branch first. So we see that we have a times here, and to evaluate a times, we have to evaluate its two operands. So this is an expression 3, which evaluates to 3, the number 3, and then this evaluates to a 4, which is the number 4. So to evaluate a times, we multiply the two operands. So 3 times 4 gets us 12. Okay? So we know we're going to do 12 minus something, but that something still needs to be evaluated. So we have a plus here. To evaluate a plus, we evaluate its children, its two operands. So we have this left operand here, which is just the expression 16. Expressions that are numbers resolve to themselves, so this resolves to 16. The right expression, the right operand, is a times, whose operands are 8 and 2. And as you can guess, expressions that are just numbers resolve to themselves. So we get 8 and 2. If we multiply those, we get 16. If we add 16 and 16, we get 32. So we get 12 minus 32, which is what? Negative 20. Okay? Negative 20. So, what's the corollary here? Like, what's the point of this? Well, we can represent all of these things as classes, right? We can have a class called num, which just has some integer v that represents an expression that is a number. Okay? We can have an add expression. Okay? Now, what do you think its two arguments would be? Well, if you think they're integers, then you'd be wrong. Because if you see that this add here, its left child, its left operand is a 16, but its right operand certainly is not a number. It reduces to a number, but it is not itself a number. In fact, these are all types of expressions. Okay? So we know we're going to have some type of left operand and some type of right operand. And if you could guess, sub and mul are going to work the exact same. They're going to have a left, and a right. Okay? Left and a right. So, but what's the commonality among these four things? They can all be evaluated. Okay? And an evaluation produces an integer, a number. So, all of these will have some method, int eval, which describes how to evaluate an expression. Okay? And we will do this by combining them inside of an interface called iExpression. Okay? So let's go to the code and see what that looks like. So, I have a test here, but we'll come back to that. To create an interface, we just right-click on here, new class, select interface. We're going to name it iExpr. And now we're going to put the method int eval. Okay, int eval. So, the four classes we have are num, we have add, we have sub, and we have mul. Okay, so all of these are going to implement the iExpr expression interface. Okay, so let's just make that addition right now. Okay, now all of these therefore have to implement the eval method. Okay, so if we're creating a number expression, what might that look like? Well, in the code it might look something like this. We have, let's say, iExpression e1 equals new num, and we can pass it some number, 42. Okay, so this creates an expression that is a kind of number. Okay, if you want to create one that is an addition, we can do something like new add, and then its left operand must be an expression, and its right operand must be an expression. So we could pass something like e1, and then new num, and then maybe 10, and then maybe we could have another one for combining them. So instead of writing them out like that, let's just write tests for them. So we'll have them assert equals for, let's say, 32, and then new num of 32. Now this is going to give us an error because we don't have a constructor for it, but that's fine. We'll come to that. So we have an add, so new num 42, new num negative 10. Okay, and then we can just do some for like subtraction. So let's create a slightly harder one. Let's do this example here. So we said it's a let's see, how do I want to do this? There we go. So let's just combine them all. So we'll have assert equals, the result is negative 20. So we'll say new sub, And then its left operand is going to be what? It's a new mul of new num 3 and 4. Okay? And its right operand is going to be what? It's a new add whose left is a 16 and whose right is a product, is a mul. So, and its left is a num and whose right is a num. Okay? There we go. So, very good. Let's see, so we don't need parentheses there. I want to try and make this as clean as possible. It's kind of hard when you have to nest things like this, but that will be fine with it. There we go. Okay, so these are fine tests, so let's write some code. So num is the simplest. Num is just an immutable wrapper around some integer value. Okay, the constructor will receive the number and assign it to the instance variable. To evaluate a number, all we do is return the number itself, because there's no way to further reduce a numeric expression. We just give it back. Okay, so the thing we're actually missing here is a call to eval. So when we're evaluating an expression, we want to recursively evaluate its components, at least when we're evaluating a complex expression like add, sub, or mul. So let's see how add works, and then we can just propagate that to the other classes. So add receives two expressions, a left, we'll just say left operand, and a right operand. Okay, left operand, right operand. So, and it will receive these as parameters to the constructor. And then how do you think we eval this type of expression? Well, all we have to do, we know we're going to have a sum in this expression, or in the returned value. So we better have a plus here somewhere. But again, we need to recursively evaluate the left-hand side by calling eval, and then the right-hand side by calling eval. And that's it. That's all you have to do. You evaluate the left side, evaluate the right side, and then we add them. And remember that the way plus works is it will just evaluate its two arguments and then add them. And as you might guess, all we have to do is copy and paste this into here, change the name, and change the operand, or the operator. Okay? That's all you have to do. Make that times, make that mul, and all tests should pass. Well, that's if it will even recognize this as a JUnit application. Let's run this, see what we get. And all tests pass. Okay? So, what we've done here is actually something very, very powerful, and it may not seem like it at first. We've actually created a very small programming language. Now, all this language supports are just basic, 3 operators and numbers, but hopefully you can see how you could flesh this out into a more complex system. Okay? And later in the chapter, we will flesh this out into a much more extensive small programming language.